Hi everyone, and thanks for joining us for section 3 of chapter 2, solving two-step and multi-step equations. In this section we're going to be looking at equations that have a lot of different terms, and we're going to move some things around. And in this section I think that non-traditional method that we've been working with is going to be the best way to do these, and I'll show you what that means here in a little bit. Here's some warm-up questions. Give those a quick look through, pause the video, work them out, and then whenever you're done please come back and check your answers. Okay, hoping that you've done these and you've done them using the order of operations, and maybe you've done them in your head. The answer's real quick here. For number 1, of course, just real quick, 9 times, and then this is multiply, so I hope you did multiply first. Negative 3 times negative 2, and got positive 6. So 9 plus 6 is going to be 15. Number 2 here, do the parentheses first. Negative 5 plus 2, or negative 5 plus 7, that's 2, and then 3 times 2 is 6. This one, the number 2 here, you have to do each the top and bottom. So this 3 plus negative 7, that's going to be negative 4, and then negative 4, and then you can reduce this here and get negative 1/3, and this turns out to be 4, negative 4. Number 4 is 18. Simplifying expressions here, you're just combining like terms. Number 5, 10c plus c is going to be 11c. Number 6, you have 8.2b, 3.8b, and a negative 12b. They're all b, so you can just add up and subtract their coefficients. When you're finished with that, you come out to have the answer of actually 0. 0b, which is 0. Number 7, I hope you distributed. Made this a 4m and a negative 14. Combining like terms here, 5m plus 4m, that's 9m. And then the negative 14 is just going to tag along. And for number 8, you want to make sure this is like a number 1 mistake of all Algebra 1 students. Negative here, you have to distribute the negative. Negative 2x minus 5, so 6x minus 2x is 4x. And then that minus 5 is going to tag along. Okay, so let's go to the, here we go. So what we're doing is looking at questions that are kind of like this. Alex belongs to a music club. In this club, students can buy a student discount card for 20 bucks. So that's a one-time fee, and it's $20. This card allows them to buy CDs for, allows whoever has the card to buy CDs for $3.95 each. And after 1 year, Alex has spent $63.40. So what you're trying to do is figure out how he's coming across this, how many CDs has he purchased. So what you're looking at here is the cost per CD, that's one charge to him, is $3.95 per CD, plus his initial cost of the discount card, which cost Alex $19.95. It gives you a total of $63.40. Now we're not going to solve this right now, but this is what these examples and these statements are going to look like. And maybe we'll come back and check this one out later. So what this is trying to say here is, notice that this equation entails a few different things. You have multiplication, which is happening with the 3.95. Here's multiplication right here. You also have addition. So it's two operations in one problem. How do you handle that? And that's what we're going to take a look at in this section. Before we move on here, there's something I didn't really point out in the last section that's kind of helpful here. And if you want to use it, you can. If you like to use the old method, that's fine. And what I'm talking about is using reciprocals when we're looking at solving equations. So if I have a question that's something like, excuse me, 2 over 3x equals 6. Now in the last section I said, well, you could take this 3, and since it's divided by 3, bring it over here and make it a multiply by 3. And then this will be 2x, that'll drop down, equals 18, and then you could take this 2 and bring it over here to the right. It's multiplied by 2, so we'll make it divide by 2, and that'll give you x equals 9. Well, there's another method to do this when you have a fraction like 2/3 or 4/5 or anything like that, and that's using the reciprocal. So if I have something like, again, 2 over 3x equals 6, I can combine both of these steps if I like. It's up to you if you want to do this or not. but I can multiply both sides by the reciprocal of the fraction in front of my x. Now what this does is it cancels each of these out. I'll write it over here real quick, just out of the way. 3 over 2x times 2 over 3x equals 6 over 6, which equals 1. So they've canceled each other out, here and here, and I'm just left with 1x, or just x. But I have to do that same thing to the right over here, so I'll be multiplying this side by 3 over 2. So I'd have 6 times 3, which is 18, and then remember there's a 1 underneath here. 1 times 2 is 2, and I'd still come up with 9. So that's just another method of solving when you have fractions like 2 over 3, 4 over 5, 9 over 7, whatever you see in front of a variable. It's if you want to use this. A lot of people like this method. It's a one-step equation. Some people don't. It's your choice. So let's start a couple here. These are two-step equations. Let me show you how I like to do this, the non-traditional method. Once again, I like to have this set up here with my little warp zone. And how I have everything set up is I like my letters on the left. I think this works out for everybody. It's worked out great in the past. I think you'll like it too. And I'm going to take all my letter terms and make sure they're on the right. Or I'm sorry, make sure they're on the left. So when I look, I see one letter term and it's on the right. And I don't want that. I want my letter term on the left. So what I'm going to do is I'm going to take it and move it over here. And that's going to become a negative 4a. It's going to switch sides. It's going to warp over and change. And I want all my number terms on the right. So I have one that's already here. This plus 10 will just kind of hang out over here and just stay where it is. But I have this 18 on the left. So I want this 18 on the right side. So all my numbers are on the same side. So that's okay. I can do that. Just remember, when I switch the sides, I switch the signs. You're going to hear me say that a lot. Switch the sides, switch the signs. So everything just kind of works out on its own here. I have negative 4a on the left equals, now I have negative 18 plus 10. That'll give me a negative 8. And here I am again with the final. It's a one step here at the end. I'll just simply divide. And I'm going to do the traditional method here. I like the traditional method when I do division. Divide both sides. Well, not by 4. Not by 8, I mean by 4. Okay. Actually, I'm sorry. Made a mistake here. Negative 4 cancels these out. And then I have negative 8 divided by negative 4. And that's 2. Let's do a couple more examples of those. Here I have 5t minus 2 equals negative 32. Again, I just want to keep all my variable terms on my left and my number terms on my right. So as I look over this, let me set up my warp zone here. My one and only variable term is already on my left, so I'm good. Now I want to make sure all my number terms are on my right. And I see that I do have one on my left, so I'm going to change its side over here. I'm going to take it to the right. So that's going to leave me with 5t on the left. Now over here, I'm going to have, it's going to be a plus 2. It was a negative 2. Now on the right side, it's plus 2. Change the side, change the sign. So negative 32 plus 2, that's going to be a negative 30. And then again, I like to just do simple division here. Divide by 5, divide by 5. Cancels those out. T equals negative 6. Here's another one here, negative 4 plus 7x equals 3. I'm going to do the same method, make sure all my variables on the left. There's my warp zone there. 7x is on the left, so I'm good. I don't have to change the 7. But I do see that I have a minus 4 on the left, and I don't want that. I want that on the right. So I'm going to bring that over here to the right side and change the side, change the sign. So that's going to be a positive 4 now. It's no longer there. So I have 7x equals 3 plus 4. So that means 7x equals 7. So x is going to equal, let me just go back here, do the work here one more time. Divide by 7, divide by 7. Hopefully we're getting good at that. I don't have to keep writing that out, but I will for the time being. X equals 1. Keep on rolling. This is 1.5 equals 1.2y minus 5.7. This one I'm going to have to change the variable term. So that variable term's right here. And I want that on the left. So it's going to be a negative 1.2y. Now I'm not going to write anything else up because I see that I have this variable term on my left. And I want all my numbers. I want my number term is on this left here, this 1.5. I want it on the right. So I'm going to change that over here and make that a minus 1.5. So when I'm done, I have a negative 1.2y equals, and it doesn't really matter how you write these. I'm just going to write it like this, negative 5.7 minus 1.5. So 1.2y equals 5.7, negative 5.7, minus a negative 1.5. Sign's the same, so we're going to add and keep the sign. That's going to get me a negative 7.2. And I'll do traditional division here. Divide by negative 1.2, divide by negative 1.2. That cancels out, and y equals 1.26. Keep on going here. Again, now we're working with a fraction, but it makes no difference what we're doing. We're going to stick with our methods here. Here's my warp zone. I want all my letter terms on my left and my number terms on my right. We'll have a letter term. It's right here, and it's on the left, so we're good. So I'm just going to take this number term over here to the right, and now I'm going to have a n divided by 7 equals, now this positive 2 is over here. It's going to become a minus 2 once I bring it over. So 2 minus 2 is 0. And then here, to get rid of this fraction, I'm going to do the traditional method. I'm going to multiply both sides by 7. Those divide out, so I'm left with n equals 0 times 7, which is 0. Easy enough. Keep on going here, a couple more examples. So once again, variable term on my left, number terms on my right. Variable term is already on my left, so I'm good. So I'm just going to take this, negative 3.4, that's a number term, there's no variables in it. I'm going to take it over to the side and make it a positive 3 over 4. Now we're working with adding, subtracting, and fractions. You will need a common denominator. If you don't, if you want to use your calculator, that's fine too. But I'm just going to do it the old-fashioned way here. Real brief. 7 over 12, my common denominator is going to be 12. Remember how to do that. So I'm going to multiply everything by 3. 9 over 12. So this is going to be y over 8 equals 16 over 12. I'm going to reduce that. I think it helps. We'll multiply everything, divide everything by 4. So this is going to be 4/3, so I'll rewrite this. Y over 8 equals 4/3. Okay, so now I'm going to do traditional multiplication here. Multiply by 8, multiply by 8, so make sure I put a 1 underneath that. Those cancel out. I have, to finish up, y equals 32 over 3, and that doesn't divide out or reduce, so we're done. Next one. Another one just like we just did. My variable term is already on my left, so I'm good here. That's a variable term. So I got to get rid of my number term, which is this 3 over 4. Take it to the other side and make it a minus 3 over 4. Cross it out. It's not there anymore. So on my left side still, I have 2 over 3r. Now I'm going to do some common denominator stuff again. 7 over 12. I'm going to multiply everything by 3. Minus 9 over 3. I'm sorry, 9 over 12. So that's a negative 2 over 12. Which actually, clean this up here. I'll write that up here. That reduces to a negative 1/6, so that's nice. You don't have to reduce, but I think it helps. This is one of those times when I'm going to use that reciprocal method. I'm going to multiply both sides by 3 over 2. You don't have to do it this way. You can multiply both sides by 3 and then divide by 2, but I'm just going to do it this way just for demonstration. 3 over 2. So my reciprocals here will cancel each other out. And I'm just left with r over here on the left. Now on the right, I'm just going to multiply across. And I'm going to bring this negative along with it. So negative 1 times 3 is negative 3. And then 6 times 2 is 12. And I can reduce that. 1 and 4. So equals negative 1 over 4. So those ones are a little bit more complicated, but with some additional practice, I think you'll be just fine. I want to skip that one too. There we go. So here's another one. My variable term's already on my left, so I'm going to leave it there. I'm going to take this over here and add it. So I'm left with, on my left side, 2x over 5. Now there's a couple different ways that you could do this. You can do 5 and 1/2, which I'm not really fond of mixed fractions. I think you should stay away from those as much as possible. So what I'm going to do is do common denominator here, which is going to be 2. So that's going to be 10 over 2 plus 1 over 2, or 1/2. That's going to get me 11 over 2. I can't reduce that, so I'm just going to leave it. Now, I'm going to show you both methods here just for practice. This first method, I'm going to do the reciprocal method. So 2x over 5 equals 11 over 2. And I'm going to multiply by the reciprocal. And I got to do it to both sides, so these will cancel out. So I'm left with x equals 11 times 5, 55 over 4. And now I'm just going to check this out with a different method, just to double check. Make that come over here now. 2x over 5 equals 11 over 2. I'm going to multiply. Remember, when we're doing like this, we want to get rid of the fraction, so we're going to multiply both sides by 5. So that gets rid of this. 2x equals, now remember this is over 1. So 11 times 5 is 55 over 2. And now I'm going to divide by 2. And then if I plugged in the calculator, that comes out to be 55 over 4 here. So either method you'd like, just to show you here, will work. There's no right or wrong method, as long as you're doing the right terms and the right practice and keeping everything in order. But so you get the same answer for either way you do it. And here's another one. We have 3 over 4u. That's our variable term. That's going to stay put right where it is, and we're going to take this over here to the right and make that a minus 1/2. So that's no longer there. So on my left side here, 3 over 4u equals, now I'm going to do that common denominator again, 7/8 minus, I'm going to multiply everything by 4, 4/8, so this is going to be 3 over 8. And I think this time I'm going to do the reciprocal method again, just for a time saver. 4 over 3. So these will cancel out. I'm left with my u. And I'm just going to multiply across here. Sorry, make this a little larger. U equals 3 times 4 is 12. 8 times 3 is 24. And I can reduce this actually. Make this u equals 1/2. Same thing again, variable terms on the left, so it's going to stay there. Number terms on the right, getting rid of it, making it a positive 1/3. And this one we don't have to worry about common denominators here. I have my warp zone just to keep on that. 1 over 5n equals 8 plus 1 is 9 over 3. Oh, hey, that reduces to just 3 over 1, which is just 3. So let me rewrite that. 5n equals 3. And I'm going to just bring this over here, change that negative, or divide by 5 to a multiply by 5, get rid of that, and I'm left with 1n is 15, or just n equals 15. Hope you're catching on. I hope this isn't going too fast for you. Oh, what happened? Let me get rid of this here. There we go. So, sometimes you have to use the distributive property. Again, this is just going to be moving a bunch of terms left and right here. It's not a big deal. So we're just going to make sure all our variable terms are on our left and all our number terms are on our right. So I see two variable terms. They happen to both be on the left, so that's okay. We're going to leave them there. So this number term has got to go over here and make this a positive 21. So now just to rewrite this, we have all of our variable terms on our left. 8x plus 5y, or 5x, equals negative 15 plus 21. Now I'm just going to combine my like terms here. 8x plus 5x is 13x. And then negative 15 plus 21 is going to be 6. And now I'm just going to divide. So my final answer here is going to be x equals 6 over 13. Next example. Now before we can start moving things from side to side, we have to take care of something. We have to distribute this negative sign. So let's do that. Take it to both of these here. So I'm going to have 10y minus 4y minus 32, minus 8 equals negative 20. So now since I've gotten all my terms all by themselves, I can move things around if I need to. All my letter terms are on my left, so I'm good. Now I'm just going to take my number term and slide it to the right. And take it through the warp zone here, the inverse zone, change it up and make this a positive 8. So now I've got 10y minus 4y equals negative 20 plus 8. So 10 minus 4 is going to be 6y. And negative 20 plus 8, that's going to be a negative 12. And here I'm just going to do my simple division. Divide by 6. Get rid of that. And y equals negative 2. Here's another one here. A little more simpler than the last. Let's see, variable terms. Are they on the left? Yes, they both are. So we got to get this number term right here and take it to the other side and change it to a negative 3. So on my left side here, 2a minus 8a equals 8 minus 3. So 2a minus 8a, that's negative 6a. And then 8 minus 3 is going to be 5. So I'm just going to do some simple division here. Negative 6, negative 6. Those cancel out, and I'm left with a equals a 5 over negative 6. Next example. Here, before we start solving for d here, we have to distribute once again. So I got negative 2 times 3 and negative 2 times negative d. Don't forget that. So negative 2 times 3 is negative 6, and then negative 2 times negative d, that's going to be a positive 2d equals 4. So the only variable term I have is on the left side already, so I'm going to take this negative 6 and slide it over here to my right. Change it up, change the side, change the sign. Make that a 6. So to rewrite, I have 2d on the left, and then 4 plus 6 on the right. Well, 4 plus 6 is 10. And then we're going to do some simple division. Get rid of those two terms, and I'm left with d equals 5. Here's another one. Again, we have to distribute. So I have 4 times x and 4 times negative 2. So 4 times x is 4x. 4 times negative 2 is negative 8. And then I just bring this over here, the 2x equals 40. Number terms on my left, or letter terms on my left, so they're there, they're good, they don't have to change sides, but this negative 8 sure does. it's got to go over here to the right. Make that a positive 8. Cancel it out. It's not there anymore. So to rewrite this all, I have a 4x plus 2x equals 40 plus 8. Okay, so 4x and 2x is 6x. 48, and I'm going to divide both sides by 6 to get rid of this. X is all by itself here, and then 48 divided by 6 is 8. Okay, so let's take a look at using these examples with some word problems. So in this example here, Sarah paid $15.95 to become a member of the gym. Typical, that's normal, that's how most gyms do it. She then paid a monthly membership fee, which most gyms do as well. Her total cost for 12 months was $735.95. How much was the monthly fee? So you got to think, if I'm thinking this out loud here, my total cost for the year. Write this over here. Is going to be equal to her membership fee. That she initially paid, plus her monthly fee. Okay, so we can fill those in with the information given in the word problem. Her monthly fee, her member fee was $15.95. Now we know that she went 12 months. Okay, and we don't know her monthly fee, so we're just going to name this F for fee. Total cost for the year was $735.95. So I can bring this all together here, and I'm going to just condense everything. 15.95 plus 12 times the monthly fee, which we don't know, equals 735.95. So what I'm going to do is I'm going to take this 15.95 over here to my right, get all my numbers on my right, my variable term stays, make this a minus 15.95. So I've got 12F equals, get a little help here from my calculator, 735.95 minus 15.95, and I get $720. So that's how much money she's actually paid right there in total monthly fees. In 12 months total, this is how much she's paid in just the monthly fee. So how much is 1 month? Well, we're going to take and divide both sides by 12. And we're going to find out here, cross these out, that's gone. That monthly fee, $720 divided by 12, is 60. So she's paying $60 per month for the gym. Okay, these are our last couple examples here, and these are nothing crazy. This says if 4a plus 0.2 equals 5, find the value of a minus 1. So what we have to do here is find a first, and then take that value and subtract it by 1. So here we have 4a plus 0.2 equals 5. So I'm just going to leave my variable term alone here on the left, and I'm going to ship this 0.2 over to the other side and change the sign. So that means I'm going to have 4a equals, now 5 is going to stay where it is, but I'm going to get a negative 0.2. I'll just move this over here and made it a 0.2, negative, and it's gone. So I have 4a equals 4.8, and I'm just going to do a simple division here. Divide both sides by 4, and this is going to get me a equals 1.2. Now to finish up here, it asks once again, what is a minus 1? Well, I know what a is. A is 1.2 minus 1. Bring that down. So when I'm done, I have a final answer of 1.2 minus 1, which is just 0.2. So not as hard as it looks. Here's another one here. I mean, this one's going to be a little bit harder just by setting up, and it's going to be a little longer. First, I have to distribute here. 3d minus parentheses 9 minus 2d equals 51. So I have to distribute the negative. 3d minus 9 plus 2d equals 51. So keep my letter terms, they're here and they're on the left, so that's good, we'll leave them there. But we'll take this negative 9 and bring it over here to the right and make it a plus 9 and get rid of it. So at the end of this, I have 3d plus 2d equals 51 plus 9. 3d and 2d is 6d. 51 plus 9 is 60. So I'm going to divide both sides by 6. I get a final answer of d equals 10. Now this one asks, what's the value of 3d? Well, I know what d is. D is 10, so I'm going to take 3 times d, which is 10, and get an answer of 30. Plain and simple. Okay, here we are at the end finally. Here are 6 questions to do on your own. We will check these over in class. Thanks so much for watching. I know it was long, but again, practice for these makes perfect in the long run. Thanks again. I really appreciate it, and have a great day.